All right, guys, Mr. Jones back with you here, and we're talking about parallel and perpendicular lines. Perpendicular, one of my favorite math words to say. It's a fun one. Anyway, we're going to talk about the difference between these and then how we can use the information and facts about parallel and perpendicular lines to do problems like we were doing in the last videos, which was finding the equations of lines. Okay, so let's just study these graphs here first, and then we will get into some practice problems that we'll do together. Okay, so obviously you can tell just by looking at the graph, right? This pink and purple line, okay, these are parallel, right? You can just observe that. But what I want to nail down today is what is it about the equations that makes these parallel, okay? Because we can observe it on the graph, but look at the equations, right? If you look at the equations, y equals 3x minus 4, y equals 3x plus 7. They've got something in common, right? They've got the same slope, right? They've got the same m value. The m values are the same, which means they're going to travel the same way all the time, right? They all move up 3, right 1, up 3, right 1. Every time they go to a new point, they move that same way, which means they are parallel and they're never going to intersect each other. And so that's something to remember, that just make that connection. Parallel lines have the same slope, okay? There are two lines that have the same slope, okay? So that's key. And you notice the y-intercept doesn't matter, right? Minus 4 plus 7, these are different. They're not really connected in any way. So the y-intercepts with parallel lines and with perpendicular lines too, these don't really matter. The y-intercept doesn't affect it a whole lot, okay? It's the slopes that we're focusing on. Okay, now looking at this one, these are definitely not parallel, right? They make a clear connection here, okay? And so these are what we would call perpendicular lines, okay? And so again, the example, the poster I have over here is of perpendicular lines, okay? It kind of gives the example of a street intersection when two roads kind of cross each other, okay? And the key characteristic of perpendicular lines is they are two lines, and you see it on the poster here, these little red little squares in the corners, okay? That signifies that it is a right angle, okay? That these two lines meet, and when they meet, they form right angles. All these angles technically are right angles, but yeah, when they meet, they form a right angle, okay? So it can't be close to a right angle, it has to be exact, okay? And that can be really tricky to tell on a graph of two lines that we're looking at, because it can look really a lot like a right angle, but it might not quite be that way, okay? So again, we have to look at the equations and say, okay, what is it about the equations that makes these parallel, and how we know, or makes them perpendicular? And how do we know for sure they're perpendicular? Well, we have to look at the equations, okay? And it's the same thing, it's the slopes, okay? It's the slopes are what tell us that these are perpendicular, okay? And it's a little bit harder, right? Parallel is super easy. It's just the same exact slope, make parallel lines. Perpendicular lines have two key characteristics, the slopes, okay? Okay, so I want you to notice the two key characteristics, okay? Perpendicular lines have slopes that are two things, okay? First off, this slope of the first line, the blue line here, is 3, positive 3. This slope is negative 1/3, okay? So the first thing I want you to notice is that their signs are opposite, okay? So perpendicular lines have slopes that are opposite signs, okay? So this is always going to be true. One of the signs is going to be positive, and then one of the signs is going to be negative, okay? That has to be true for them to be perpendicular. And then the second key, okay, so one's positive, one's negative. The second key, this one's 3, and this one's 1/3. Okay, so there's a fancy word we have for that. Reciprocal, okay, reciprocal. You might remember that from middle school, but a reciprocal is like the flipped version of the fraction. So the first slope is positive 3, or 3/1, okay? If I made the reciprocal of that, it would become, right, just flipping it around to 1/3, okay? So again, that has to be true as well. Okay, and these both have to be true for them to be perpendicular, okay, not just one of them. So 3/1 and then negative 1/3, okay, opposite sign, and then flip around the fraction. That's what I often say. Flip the sign, flip the fraction. That's where they're perpendicular, okay? So that's key that we know that going into this, okay? That's kind of your base background knowledge of perpendicular lines and parallel lines, okay? So we're going to use that then to answer questions like we did in the previous videos, okay? So we're going to get into those right now. Okay, so I have up here an example we're going to do together, but I have up here the two rules. Parallel lines have the same slope, perpendicular lines have to have these two qualities of their slopes, okay? And so we have to keep these in mind when we do problems like this, okay? Because these are a little bit like word problems. We have to break down what it gives us and then use that to help answer the question, okay? So here it says find the equation of the line. So again, anytime it wants us to find the equation of a line, we're thinking mx plus b, okay? So again, our job is to find the m and the b values, okay? And so we have to use what it gives us to be able to find that, okay? So we have to find the equation of the line that goes through the point 3 comma 2, okay? And is parallel to the line y equals negative 2x plus 7, okay? So let's break down what it's giving us here, okay? So again, what we would look for is the slope and the y-intercept. Those are the things we need to answer this question, okay? Does it give us either of those? Well, not directly, right? It doesn't say the slope is this and the y-intercept is this. It doesn't say that, okay? And again, check for your shortcut. Does it give you 0 comma something as your point? No, so it doesn't give us the y-intercept that way either, okay? But we are given two pieces of information, okay? It goes through this random point, and again, that's going to be an x and a y value for me that I can use, okay? And we're given this new piece of information, okay? It says it's parallel to the line y equals negative 2x plus 7, okay? So all I know, just to sketch it out, okay? All I know about this line is that it goes through 3 comma 2, so 3 comma 2, like right here. And there's this whole separate other line. So negative 2x plus 7 would be like that, okay? There's this whole other separate line, okay? And I'm told that, okay, we have a line that I'm trying to find, and it goes through this random point, and it's parallel to this, okay? So think about that, okay? I have to use that to find my equation of my line that I'm trying to find, okay? So what do we know? Okay, so again, using these two rules, okay, about parallel and perpendicular lines, okay, right? These lines are parallel. It says parallel, right? My line that I'm trying to find is parallel to this one. So what does that mean? Right, the slope of this line, the m value of this line that it gives me is negative 2. And if I use that rule, parallel lines have the same slope. I make that connection, and I know that, okay, if this slope is negative 2, and parallel lines have the same slope, my line also has to have a slope that is negative 2, okay? So this is kind of a less clear way of giving you the slope, okay? If you're told that your line is parallel to another one, you're basically being told what the slope is. You just have to look into this equation and see, okay, this slope is negative 2, so that means that my slope is also going to be negative 2. So you have to kind of make that connection, but it's a way of giving you the slope, which is helpful, right? It's awesome when it gives us the slope, so then we don't have to do that nasty slope formula. And so then now, right, I have my m. Still don't know what b is, though, so I can't quite be done with the problem yet, okay? But I do know that it goes through this random point, okay? So I have to do that process where I take these values, take my m, and I plug them in here. Okay, so I plug in 2 for y, so 2 equals m times x, so negative 2 times, negative 2 times 3, m times x, plus b, okay? So I plug in what I know, what I'm given, and I solve for this unknown, this b value, okay? So 2 equals negative 2 times 3. Negative 2 times 3 is negative 6, okay? And so I have this negative 6, okay? And so I need to get b by itself, so I add it to both sides to cancel it. And so now I have 8 equals b, so my b value is 8, positive 8, okay? And that was the last piece of the puzzle that I needed to fill this in, okay? So my answer, my final answer is going to be y equals negative 2x plus my b value that I found plus 8. Okay, that is the equation of my line that it's asking for, okay? And yes, it's going to be parallel to this because they have the same slope, right? And so that's good too. Okay, hope that makes sense. I'm going to do one or two more, and then that'll be it. Alrighty, I got number 2 up here. Number 2, similar, but it says find the equation of the line that goes through the point negative 7 comma 0 and is perpendicular to the line y equals 1/2 x plus 3. Okay, so again, look at what I'm given here. Am I told the slope and the y-intercept? No, I'm not explicitly, okay? I look at this point. You might be thinking, oh, I see a 0. Is that the y-intercept? It's not, unfortunately. Okay, I wish it was because that would be a lot less work. But again, it's when 0 has to be the y, the x value. 0 has to be x. So 0 comes first, and then whatever number after that is the y-intercept. But no, this is an x-intercept, and that doesn't help us, unfortunately. Okay, and it's perpendicular to the line y equals 1/2 x plus 3. Okay, so let's think about this. Again, my goal of the whole problem is to find my equation of the line. Okay, so I need to find the m and the b value. Okay, and so let's think about that. I don't know either of these right away, okay, because it doesn't tell me them clearly, but again, I'm going to use this point. I'm going to use this point, plug that in here eventually, okay? But let's think about this. Perpendicular to the line here. So it's kind of the same as the last one where I'm given some random point and I'm told some other totally separate line that it's perpendicular to, okay? So again, sketching that and drawing that out can help, okay? So negative 7, 0 is like here. The line 1/2 x plus 3 would look something like this, okay? So I'm told, okay, my line is going to be perpendicular to this. Again, that doesn't mean parallel. It means meets it like a right angle. So hits it and hits it very clearly, okay? And that it goes through this point, okay? So that's what I know, okay? So let's think about, okay, using what I know and what I'm given, how can I solve this, or how can I find the answer to this? Let's look at this, okay? So perpendicular lines have slopes that are opposite signs and are reciprocals, okay? So again, this random line that I'm told about, okay, what slope does it have? It has a slope of positive 1/2. And so using that, okay, I'm told that my line that I'm trying to find is perpendicular to this. So that means 1/2, positive 1/2, okay? I'm going to take that and I'm going to do these two rules to it, and that's going to tell me what my slope is, okay? So again, this is a really kind of like unclear and indirect way of giving me the slope, okay? If I'm told that it's parallel or perpendicular to this other random line, okay? So let's think about this. If the slope of this line is 1/2, okay, my slope is going to be the opposite sign, okay? So if this slope is positive 1/2, my slope is going to be negative, right? Opposite sign. And then reciprocal, okay? So taking the reciprocal of 1/2, flipping it around would be 2/1, right? Flipping it around. So I could say negative 2/1, but again, 2/1 is the same as just 2, right? So negative 2 is the slope of my line, okay? That's what I know. If I know that it's perpendicular to this, I can take that slope, flip it, opposite sign, and that tells me my slope. So again, this is telling you that it's perpendicular is a really indirect way of telling you what the slope of your line is. You just have to do a little bit of work to find that, okay? But now I know the slope. Awesome, that's half of my puzzle here, okay? So negative 2 is going to go in for m, but again, I need to do that process of plugging it in here, okay? 0 in for y, negative 7 in for x, negative 2 in for m, just like we've done, okay? So 0 equals negative 2 times negative 7 plus b, okay? And so I take that, and negative 2 times negative 7 is positive 14. So 0 equals 14 plus b. I minus 14 from both sides. So 0 minus 14 is negative 14. So negative 14 is my b value, okay? And so I take all that, okay? That's my second piece of the puzzle that I didn't know. I got this one, I got that now. And so my answer is going to be putting them together. Y equals negative 2x minus 14. Okay, there we are. So I hope that makes sense. That's just a little bit about parallel and perpendicular lines. I might have to get into a little bit more later, but that's it for now. Good job. Thank you for following.